Hello, everyone, and welcome to the third episode of the Pawsey Capital Refresh podcast. I'm here today with Mark Gray, the head of scientific platforms at the Pawsey Supercomputing Centre, who has been instrumental in the high throughput cloud procurement.
Hi, Didi.
Hi, Mark. So, Mark, what exactly is this high throughput compute system?
Hey, Didi, for the last 2 years, Pawsey has been operating a service called Nimbus, the research cloud at Pawsey Supercomputing Centre. As part of our capital refresh program, we're replacing all elements of our computing infrastructure, and the first part of the computational infrastructure to be replaced is our cloud facility. Cloud's a frequently misunderstood term in computing, so they'll look outside and tell you it's a big ball of kind of fluffy water. In our case, our cloud is an entirely on-premises facility here at Pawsey, integrated with the rest of our infrastructure. So it's really, we say cloud, what we mean by that is that it's just a very flexible infrastructure. Researchers can shape it to be the infrastructure they need at the time they need it, and then when they're done with it, they can just get rid of it, and other researchers can make use of it.
So if this is infrastructure that's going to be remotely accessed by our users, but physically at the Pawsey Supercomputing Centre, what kind of work is going to be involved in setting up that infrastructure here and deploying it?
The process of actually getting this new infrastructure running is both very simple and at the same time kind of complicated. It's simple because users won't see much of what actually happens. It's complicated because what we have to do is a multi-stage process of getting our new infrastructure up and running, migrating data and users to the new infrastructure, and then decommissioning the old infrastructure. The actual delivery process and getting all the equipment delivered is the first part of that process, which begins now that we've completed the actual financial procurement for the facility. We're expecting at the moment that will start in the later part of this year and be a process through the early part of 2020. The majority of the transition for users is actually going to be the storage transition. So when we're deploying a new system like this, what we'll be doing behind the scenes is, as soon as our storage nodes arrive, we'll be deploying those and getting them up and running, and then we'll immediately start a migration from the current storage nodes to the new storage nodes. That'll actually happen in the background as people continue to use the cluster, and at some point that will be complete. Now, when that's complete, we can decommission the old storage nodes and we're good to go. Right about that time, we expect to be getting the compute nodes being delivered, and we'll get those integrated. And then as the rest of the hardware finally arrives, we'll be able to get the new compute up and running. So what users will see as they get up and running on the new compute nodes is simply much faster infrastructure.
And so with this new infrastructure, are they going to be given any additional training and support throughout the new year?
So we're in the process right now of working out what additional training and support we need to provide to users to help them through this transition process. And yes, absolutely, we'll be providing both training and support to users. So training in the form of public classes or even web-based classes where we'll be explaining to users the differences to the new system and the way it's being managed with examples of how that's going to work. And then support is going to take the form of specific assistance with particular users who have complicated needs and making sure those needs can be fully supported on the new infrastructure.
Okay.
And that's kind of done on a case-by-case basis.
Yeah. Sorry, I guess what everyone wants to know is who is the successful vendor?
The successful vendor was Dell EMC. They provided the best bid through the process for the infrastructure, and we're able to provide and articulate the best value for money for our government expenditure.
And do you have a bit of an overview of what system they're going to be getting?
Sure do, Aditi. It's going to be pretty cool. So we're expecting about 58 node compute cluster that'll have about 3,750 brand new AMD Zen 2 cores. So that's a lot of kind of technical blib, which just means they'll be really fast. Now, each of those nodes has a terabyte of RAM, and we'll be able to deploy some of those nodes on a case-by-case basis to users who need high memory nodes. But otherwise, what they'll be used to do is to achieve quite a lot of overcommit on the nodes. So in a cloud facility, we overcommit cores and we pretend there's more than there actually is, and that's how we get good usage out of the actual compute. So when we deploy this with 64 cores per node and 58 nodes with a terabyte of RAM per node, we should be able to achieve up to maybe 15,000 virtual cores across the system, which will be available to users to run jobs. And then on the storage side, it'll be a huge increase in storage.
So how much more storage are we going to be getting into the system?
So altogether, we'll have about 5 times more memory in the system than we do in our current cloud cluster. Storage, we will have 25 times more storage in our new cluster than we had in the old one. So altogether, we should have somewhere in the vicinity of about 7 petabytes of storage in our cloud facility available for users, and that's going to be made available through direct volume storage and also object storage, which we're going to be delivering as a service to users. The other service we're going to add as we get into the early part of next year and get the system up and running is a Kubernetes as a service provision through something called Magnum, which will allow people to run orchestrated containerized workflows in our system, and it's going to be something we're going to be promoting and also doing a lot of training around in the new year.
Awesome. That sounds really exciting. So I think to summarize, this is you're putting a system into Pawsey that is going to help our researchers and adopt some technologies that they haven't been able to use before as well.
Absolutely, Dee. Look, we're really excited to actually get researchers up on this system. It's been a long process to actually go from the original phase of figuring out what we wanted to get and then working out what we would get through the vendors and then actually getting a system deployed. But the cool part and the part that motivates our staff is what our researchers are actually going to do with it. And our researchers are going to be able to do a lot more work with the system than they can with the current one. And they're going to see much better integration as we go through the rest of our capital refresh with this infrastructure, with the other infrastructure that we're going to deploy.
That sounds exciting. Cool. Well, thank you very much for joining me on the podcast today.
No worries. See you later.
Thank you all for listening once again to the Pawsey Capital Refresh podcast. We're hoping to have another episode out by the end of the year with a bit of an update and a wrap up for what 2019 has been for the Pawsey Capital Refresh and what we can expect in 2020, 2021 and 2022. As always, we have a survey attached to this podcast, so please provide your feedback. We'd love to know what topics you'd like covered and any updates that you'd like to see as well. Thanks for listening.